Good afternoon. This is Dr. R. Vijay Kumar Reddy from KL University. Today I am going to be discussing about the topic regarding to the course code design and analysis of algorithm. And today we are going to be seeing the topic about 0 by 1 knapsack problem. In CO2 also we have gone through this knapsack problem. The problem is similar to the optimization problems. Here we are going to be using this knapsack to optimize the weight of the given capacity, that is nothing but a knapsack capacity. The problem statement here is going to be used is 0 by 1 knapsack optimization. This is similar to the dynamic programming algorithm. Here we have to go through some of the parameters like Wi, where positive integer weights of positive integers of if you are going to be taking n value, small n value, which is going to be the number of objects, then we are going to be having w of I positive weights, and same for the n value are going to be having p of I, which is nothing but n profits, which is also going to be the positive, and where m is the knapsack capacity. Based upon this knapsack capacity we have to generate the optimization weight, that is nothing but max weight, that is given here in the bottom here, mentioning here. Okay, here it is mentioned here the max we are going to be considering profit, that is nothing but an p of I into x of I, where the x value where the I value lies between 1 to the given n value. Same for that, we are going to be calculating the w of I into x of I, where it is going to be the weights of the positive n values, and we have to check that this sum is going to be less than or equal to the knapsack capacity, that is nothing but n small m. Here the x of I already mentioned between 0 to 1, that means for 1 you are going to be considering that object, for 0 we are not going to be considering that object. Coming to the solution, here we are going to be using a bounding function. The bounding function is going to be helpful to keep the node to be live, or it is going to be also used to calculate the upper bound. Whenever we are going to be calculating the upper bound, this is going to be deciding that whether we have to kill the node or we have to keep the node available. That is what here mentioned. The bounding function are needed to help kill some live nodes without expanding them. Based upon y means even if you are expanding, we are not going to be getting the optimization solution. And the good bounding function for this problem is obtained by using the upper bound. This we are going to be calculating when we are going to be using the algorithm. The solution for this one is that we are going to be assigning initial profit and weights, where we are going to be taking the first object weight and checking for the first object weight is lesser than or equal to the capacity. Here the capacity what we are going to be equal to, where we are going to be taking the capacity as m. Okay, if it is been less than that capacity, then we will include that object and we will consider the k value equal to 1. Again, if you are not going to be if we are adding that capacity and it is greater than, if it is greater than that m value, then we have to go for the bounding function, where we are going to be using that bounding function to backtrack the process to get that value. When we are going to be bounding process, then we will go for the next object. If the object weight is exceeds the object that not fit, that is what here mentioned, that not fit means, then we will keep that object as 0. That means we are not going to be considering that object. That's why the k value we are going to be giving as a 0. We will going through the bounding function. The bounding function is determined as an upper bound, one of the best solutions to obtain at k level 1. And here is the sample example problem we have taken. Okay, for p, w and m, but in our example we are going to be taking some other problem regarding to this one. And finally we will generate an state space 3 where it is going to be generated to get the optimization solution. And here is the algorithm for us, the backtracking solution to the 0 by 1 knapsack problem. The algorithm is going to be having the binary knapsack. Here we are considering the k value and current profit, and the next one is the current weight. Based upon that, we are going to be processing, and then we will going to be generating the left child, where we are going to be generating when we are considering the k value equal to 1. That is what here mentioned. And then we will go for to calculating the recursive process, again calling to the next left child if it is been satisfied, or if it is not, means then we will going for the bound function, where we are going to be calculating the upper bound. Based upon that, we are checking with the final profit. If it is been greater than that one, then we will going to be generating the right side of the value, where we are going to be considering the y1 is going to be, the k value is going to be 0. That we are going to be considering, and we are generating again the knapsack k equal to k plus 1, and again we are going to be processing. This is about the algorithm. And now we will see the bound function. Here in the bound function, we are going to be taking the current profit, current weight, and the k value, the current object value, which is nothing but the index last item what we are going to be taking. Based upon that, we are going to be assigning b value and c value, and we are iterating the loop. We are iterating the loop and checking that the sum of current weight while we are adding, whether it is going to be defined, if it is the current weight is less than the m capacity, that is nothing but a knapsack capacity, then we are going to be summing that one of the profit. If it is not like less than that one, means then we are going to be returning the value of this function, that is nothing but a b plus 1 minus c of c minus of m by w of v of I into p of I. We will calculate, and we will return this one to the back to this bound function here. Based upon that, we will start processing our right child process, and that is nothing but when we are going to be generating an state space 3, we will go for the right side process by considering. Okay, this is about the algorithm. Now we will go for a small example by considering this small example. Here we will take the k value, I am taking the n value equal to 4 and m value equal to the max F capacity equal to 8, and now I am going to be taking the k value 1, 2, 3, 4 values. Then I am going to be taking the p of I value. The p of I value equal to 1, 2, 5, 6, and the w weight value I am going to be taking initially 2, 3, 4, 5. This is what we are going to be taking. Now to start our process, already we previously discussed that we have to calculate the ratio. Here it is clearly mentioned that we are going to be calculating the number of weights, where we are going to be calculating the ratio, that is nothing but, and we are going to be calculating the p of I. Then we are going to be finalizing our sorted process of algorithm, which is going to be used in this example. Now I am taking the p of I by w of I like that. Then we are going to be getting 1 by 2, first one. For second one, it is going to be 2 by 3. The third one, it is going to be 5 by 4. The fourth one, it is going to be 5 by 6. If you are going to be calculating this one, you are going to be getting 0.5. For 2 by 3, it is going to be 0.66. For 5 by 4, it is going to be 0.25. For 5 by 6, it is going to be 1.2. If you see here, to sort, then we are going to be getting the profit 5 and the weight 4 has the first object, and the second one is nothing but then the second one, 6 by 5 here, and the second one we are going to be getting here is an 6 by 5. The third one we are going to be getting is an 2 by 3, and the last one we are getting is an the updated weight in an order, that is nothing but one P of I, W of I. This is what we are going to be taking. Now we will see that algorithm regarding how we are going to be generating the nothing but n state algorithm. Before seeing that algorithm, where we are going to be generating the state space tree. We will generate the state space tree now. I'm initially starting with C of P and C of W and K value. This is the input for the algorithms, and then I'm going to be considering F of P and F of W, which is going to be the final profit. Once we have generated, then we are going to be getting the Y values, Y1, Y2, Y3 and Y4, which is nothing but final objects, where you are going to get this we are going to be generating, and this going to be copied into x1 into x1 comma x2 comma x3, where is then optimization objects what we are going to be getting when we are going to be generating a final solution. Now we are going to be generating a tree where we will start with an CP and CW. The initial process we are going to be taking 0, and the K value we are going to be taking 1. Now if you go for the algorithm, if you check the algorithm, Y of 1 equal to 1, then what you are going to be doing means you are going to be summing the process. Here the profit equal to 5, then we are going to be adding 5 here, and here the weight equal to 4, then we are going to be adding weight here. I will show you that in the algorithm so that you can understand how it is going. Here we are generating the left child. We are checking for that one 0 CW initial process. What we are going to be 0 this one CW plus W of K. The initial weight is going to be 5. We are going to be adding that is less than 8. That means 0 plus the weight we are going to be taking is a 4. Then what you are going to be getting 0 plus 4 is less than 8. Then we are going to be considering the K equal to 1. Then we are checking K less than or equal to N. Our K value is 1, and the N value what we are taken is n 4. That means 1 less than 4. Then we will call that K plus 1. That is means K equal to 2. Then what you are going to be doing means CP plus KW. That means we are going to be adding initial with that profit 5. Then we are going to be doing that initial weight 0. That weight we are going to be adding 4. That means what you are going to be getting 2 comma 5 comma 4. This is the next process what we are going to be hit. And now again we will take considering Y equal to 1. Then if you are going to be calculating here, the Y profit is going to be 6. That means if you are going to be adding 5 plus 6, it is going to be 11. Then 4 plus then 6 I completed. Now 5 is there. 5 plus 4 equal to 9. Now if you check the condition here, the weight is 9. Actually the initial capacity is should be less than. This is the condition we are going to be applying in the algorithm. It is not going to be satisfying. Then what you are going to do means you are going to be processing the bound function. That I will show here. Here the condition we are going to be applying that W of previous weight is 4 plus now current weight is 5. Then what is going to be less than or equal, then it is not going to be. Then we are coming out of here and we are generating the right shell where we are going to be checking the bound function. Now what is the bound function here we are going to be having is the bound. Here we are going to be calculating the bound function. What you are going to be calling means bound. First we are passing the profit 4, 5. Then we are passing the weight, and then we are sending the K value. That is going to be passed here. Now we have to calculate that one. Now we are moving to the bound algorithm. What we are going to be assigning is we are taking that one parameters and we are assigning B equal to this process. This we will check. Now what we are doing here, B equal to CP and C equal to CW. We assign that one. That means what we are passing here is bound of 5 comma 4 comma 2. Here the B is 5, C is 4 and K is 2. Now the iteration of the loop is going to be happening I equal to 3. Now what you are going to be doing here, you are going to be adding that profit. Now what is going to be means 5 plus 2, that you are going to be getting 7 B value. Then C equal to 4 plus 3, then you are going to be getting 7. That means the updated B is 7 and C is 7. Again you will iterate the loop I equal to 4, then what you are going to be having 7 plus 1 equal to 8, the B value equal to 8 and the C value equal to 7 plus 2, that is going to be 9. Whenever you are going to be getting this one, here that if it is been, if C less than M means, then we will do that one. Previously for I equal to 3, for I equal to 3 we having the value less than. For I equal to 4, if you see, the C value is going to be 9 and the M value is going to be 8. That means we are going to be to the else condition. What is the else condition here is B, we are going to be having 7 plus 1 minus what C is going to be. C is also going to be 7. What is your M value? 8. Then what is your weight? 2. Then what is your profit here? 1. That I will show you in the example what I have taken. See, the W value is equal to 2 and the P profit is going to 1. From that we are going to be calculating the return value. The return value, what you are going to be getting here is 7 plus 1 minus C minus M, that is equal to 1 by 2 minus 1 by 2 into 1. That means what you are going to be getting means 1 plus 1 by 2 into 1, what it is going to be means, 1 minus, then what is going to be means 7 plus 1 minus 0.5, then final what you are going to be getting is 7.5. That means you are going to be getting here the bound value is 7.5. Now we will check that bound value with the algorithm here. This we calculated the bound value, we got the here. Now we are checking the bound value 7.5. The 7.5, the 7.5 is greater than f of p. What is the initial f of p we have taken means we have taken 0, then is satisfying. Then what we are going to be going, we are going to be backtracking and you are going to be considering the y value. Here the y of k, that means the y of 2 you are going to be taking, and the 2 the value you are going to be taking is equal to y of 2, k value equal to, then you are going to be backtrack and you are going to be generating the right child. That is a very important one in this concept. Now we are going back and we are going to be generating y equal to 0. Then what you are going to be getting means you are not considering this node, means the same profit and value are going to be. Now if you see the algorithm, again we are going back. Now what we are going to be considering k less than m. What is our k value here? The k value is 2 and it is been less than n. N is nothing but a 4. Then what we are calling again knapsack of 3 comma initial value 5 comma profit and 4. That means we are calling back to that process. What you are going to be consider means we are going to be getting y3 equal to 1. Then what you are going to be adding, you are going to be adding this values. What you are going to be getting here 5 plus 2 7, 3 means 7. Again we are going to be generating the same y equal to 4, the n value. Then what you are going to be getting here is, if you see here, if you add here, you are going to be getting a profit 8, and what you are going to be getting here is 9. That means the value what you are going to be taking here again greater than. Then what here also we have to do is that we have to kill this node. If the item is not going to be generating, then what we will do is we will kill this node, and again we will backtrack. We will take y4 equal to 0. Then what you are going to be getting here is 7 comma 7. Now if you see, this is the maximum node. That means we have reached to the n value 4. If you reach the n value 4, then what you are going to be that again you have to process. From here you have to process, and if you generate the right child for this, again considering that y equal to 3, that value will not be greater than 7. If you calculate it also, you are going to be getting that value is not greater than 7. That means there is no need to continue this process. Why? Because the maximum value in this left from here, if you consider from here, if you start, the left 3 is 7. Then what you are going to be doing here is we will copy the left side process here. If cp plus k and k equal to n, that means our k value is 4 and n value is 4, then what we are doing, we are adding that final profit to where we are giving that final, we consider that f of p and f of w is the final, then we are giving that final value 7 comma profit and 7 the weight. This is what you are going to be getting, and you are copying that y values, that means the y value of binary information is going to be copied here. If you see here, now if you see here, this is the tree what you got, this is the tree. That means what you got here is the y1, y2, y3 and y4 objects are going to be copied into x1, x2, x3, x4, and final profit are going to be copied here. The final profit and final sum is this one, that is nothing but a 7 7. Now what you got here, y1 equal to 1, that means we are going to be copying here 1, then y2 equal to 0, then y3 again we are taking 1, then y4 the final one here, the y4 what you got here 7 comma 7, that we are going to be taking 0. This is what you got in the from here. The initial to the left subtree is binary format 1 0 1 0. This is the profit, and the profit you got here is 7. Now from here you will backtrack. From here you will backtrack. I will take a new page. I will write roughly about that one. We have taken 0 0 CW. F of p is equal to 7 now, and f of w equal to 7. If you go here, y we consider 5 comma 4, y1 equal to 1, then y2 we got here 9, here 8. 1 minute, I will take that table so that I will write the table here. K of I, P of I, W of I for 1 2 3, the updated values what you are going to be having 5 comma 4, second one is 6 comma 5, third one is 2 comma 3 and 1 comma 2. This one we have taken. Now if you calculate it here, sorry, you will get here 11, correct in previous also, well correct here, you will get here 11, here it is okay. You will get here 11. Now we will kill this node. Why? Because it is not going to be further using for maximization. Then we have gone for the right child generation by finding the bound function. The bound function we have got here is 7.5. Then we will take 5 by 5, then y equal to 3 again with 1, and then you got 7 by 7, then y4 equal to 1, then what you got here 9, and max profit is again we have got the n, the CW is greater than of n, then what you are going to be killing the node. Then you will go for y equal to 4, then you will get 7 comma 7. If you generated here the left child also, you are not going to be getting this one. Okay, this is what we have got for initial left side. The x of I value from 1 to 4. If I am taking I is done or equal to 4, then we are going to getting y1 0, y2 and x1 0, x3, and max profit you got 7. Now after backtracking again we will check this process. Now we will taking y1 equal to 0 initial, then Here from here we will go for again the left child y2 equal to 1. Then what you are going to be doing means you are going to be adding this one 4, sorry, we have to take the next process here. What you are going to be y1 completed. Now what we are going to be taking here is y2 equal to 1. Then what is the y2 value here? The y2 value, the initial profit is going to be 6 and the weight equal to 5. Again you will go for y3 equal to 1. Then what you are going to be getting? The m value equal to 8 and the y value equal to 8. Again if you go y1 equal to 1, then what you are going to here, the m value is going to be 10 and the profit you are going to be getting. If you see here again it is violating, and so that we will kill this node. We will backtrack here and we will consider y4 equal to 0, the right side. So far we have generated the left side condition of the algorithm. Now we are going to be generating the right side condition of the algorithm. Now what you are going to be getting here is 8 and 8. Now we have came to the n value. If you even generate backtracking and this side means you are going to be getting the max profit is also going to be less than or less than the 8 also. That's why we are not going to be considering this one. Now if you see here, what is the process you got here means we started here and we gone this side and finally we reached here. That is the values y1, what you get y1, y2, y3 and y4 you got a values like y1 equal to 0, y2 equal to 1, y3 equal to again 1 and y4 equal to 0. Again previously we have seen in the algorithm here how it is going to be. Once we are going to be generating, again what we are saying CP greater than profit. What is our current profit? The current profit what you have got here is 8. Now we are checking with the previous one, the current profit is greater than 7. Then what you will do, you will go inside and k value equal to 4. That means we reached to the k value 4 and the n value is 4. These two conditions are satisfied. Then we are going to be doing that. The current profit we are adding into the final profit. That means the final profit here it is going to be 8 and the final weight is also going to be the 8, and we are copying that y of values into x of values. That means we are going to be copying here this y of values into x of I values. The maximization what you are going to be getting here is 0, 1, 1 and 0. This is how the process where you are going to be getting the maximum profit. The maximum profit we are going to get here is 8 and the weight also you are going to be 8. This is what we have updated, and this is how we are going to be defining calculating the if you're going to be taking the objects. Here I have taken the n value 4 and the k value nothing but here I have taken n value, and here I am considered the knapsack capacity as 8 and I have taken the p of values this one. Okay, by considering this one, this is the our final object and where we are going to be providing the binary solution to get the that means the nodes, the objects we are going to be considering that second and third nodes we will get the maximum profit. Like that we have to check for any problem what we have given in the example. This is the algorithm and this is the bound function, and finally this is the questions for you. Fractional knapsack, we have seen only the 0 by 1 knapsack, and this is an example for you to solve. Okay, and finally I want to conclude that whenever you are going to be generating a 0 by 1 knapsack, you have to consider we have to generate an state space tree. Based upon that state to generate that state space tree, you have to use this algorithm for generating the left and right childs. To generate the right child, that is nothing but a backtracking process. You have to find the bound function. That is what we have discussed here. The bound function is going to be used to help in killing some live nodes, and how it is going to be doing means by calculating the upper bound of the value so that it is going to be the feasible solution. Okay, thank you.